probability. Am I recording? I am. Good. All right, so here's the deal. Frenet frame is three vectors that are like this. It's three vectors that ride a curve. And they're mutually perpendicular, and they're all unit vectors. So we're going to do one all the way through, and here's how we do it. You start out with a curve. Here's my curve. This is my curve right here. It's a helix, but it's an ellipsoidal cross-section. It's not circular because of that 2 on the sine t. It's an oval in silhouette instead of a circle in silhouette. So I'm just following all these formulas here. And we're going to do the curvature. And the curvature is t prime divided by r prime. Each of those things as length. The length of each of those. That division problem. So I have to do t prime and r prime. We're going to use t equals pi, because for Frenet frame problems and for curvature problems, I'm never going to ask you the general case because they're brutal. But you have to be able to do the derivatives you need to do in order to get the numerical vectors and numerical lengths required. So starting off, I need to get big T. And big T is r prime divided by the length of r prime. So I can get r prime. It's really easy. There's r prime. And here's the length of r prime in terms of t. Now, I can do right now, put in the pi, like you can see I'm doing right there. I can put in that pi, and I get big T. This is a unit vector, because the length of this vector is square root of 5. So it's a unit vector like it's supposed to be. So that's this guy. I got big T. Next up is big N. And big N has the formula big T prime divided by the length of big T prime. So that's the hassle. That's the hassle. I need this version of T. And I have to take the derivative of this with little t still in it. And it's actually going to be a scalar function times a vector function. So here's t prime down here. I took the derivative of the bottom. I took the derivative of r prime and took its length. And there it is. I didn't do the length yet, but I've got r prime. So to do r prime, we have r prime here. So I have to do the derivative of r prime times 1 over the length of r prime, which I have. That's my t. Now I have to take the derivative of that to get big N. Oh, what a pain in the butt. So here's the calculation for big T prime. So I have big T. It has to be big T in terms of little t. Take its derivative in terms of little t. Then you have to divide by how long that is. But once you have that vector, once you have t prime, you can put in little t equals pi, get numbers, and then you get this thing. This guy, when you put in t equals pi, turns out to be pretty clean. It turns out to be that nice. So there's big N, and notice big N dots with big T to 0 because these guys are supposed to be mutually orthogonal and unit vectors. So that's a nice unit vector, 0, -1, 0. So that's good. Now you want to probably do the details by hand yourself. Next up is big B, and big B is N cross T. Well, that's an easy cross to do. It's this guy crossed with this guy. So where's my big B? I had him up here. I must have erased him. Big B turns out to be a 1, 0, 2 divided by square root of 5. And you can see big B dots with the other two vectors to give 0. So they're mutually orthogonal and they're all of length 1. Now back to the other thing we're doing, which is curvature. What's the curvature of the helix? Well, I'm never going to ask you the general case, but I will ask for curvature of a helix at a point. And the curvature formula I'm going to use is the length of, let's see, where is it here? It's supposed to be the length of t prime divided by the length of r prime at t equals pi. So if you notice, I do have t prime done. I do have r prime done. Get those vectors at pi. Here they are. And then just do that length. Do the length of each of those guys. And it turns out to be 1 over 5 square root of 5. Again, you want to do that yourself. But the ideas are up here. So you can do that stuff. So the main thing is, any derivative you have to take, it has to be while little t is still in the problem. But once you take those derivatives, the ones that you need, you can now put in pi. But notice how big N, I have to do the derivative of big T while the little t's are still in the problem to get N. Even though I have the unit vector t, it doesn't help me find this thing. Okay? All right, see you later.